Welcome back to the NCR News Station. My name's Amanda.
And I'm Jaden, and today we're discussing the impact that HIV has on an individual's life.
In 1996, the total life expectancy for a 20-year-old person with HIV was 39 years. In 2011, the total life expectancy bumped up to about 70 years.
The survival rate for HIV-positive people has also dramatically improved since the first days of the HIV epidemic. We turn to Julia and the researcher Raquel for full insight surrounding the topic.
Hi Jaden, hi Amanda. So today I'm here with a researcher to find out more statistics and information on this interesting topic. So Raquel, why is this topic so important to research?
Yeah, researching this topic is extremely important for our society because it gives us a better understanding of where HIV occurs the most and how much it really affects a person's life. When looking at data, if there's one country that has a lower life expectancy than another country, we can see that this country may have a worse environment than other countries and may not have the tools and medicine to help with this HIV.
From your previous research, what gender has a lower life expectancy?
The histogram for male life expectancies displays a unimodal distribution as it portrays characteristics that are similar to this distribution. To begin, there's one dominant peak that is higher than other peaks of the data. Furthermore, there appears to be outliers as the frequency of data between 55 and 60 years is much lower than other frequencies. First off, there appears to be no apparent patterns in each bucket as there are some that are uniform, some that are considered as outliers, and some that are in between. Based on the unusual characteristics of the graph, we are able to prove that this is a random distribution.
And how does this connect to HIV?
Displayed on the graph, we can see that the higher levels of HIV than the lower life expectancy. We can observe that countries with HIV percents that are over 6% begin to have a life expectancies only exceeding around 50 to 70 years for both genders. This proves a strong correlation between the two variables.
Thank you so much for sharing your insight about this topic. I'll be joining Amanda and Jaden later in the newsroom for more details on this topic, right after this commercial. Stay tuned. I can't do this.
Welcome back to the newsroom. Amanda and I are now joined by Julia, who recently interviewed HIV researcher Raquel. So Julia, what have you gathered from this interview?
Well, when we look at both graphs, it shows us the mean for males is around 70.63, and the mean for females is around 75.67. But what does that really mean?
What the mean of the graph is trying to tell someone is that this is the overall average of the total data. For males, the average life expectancy is around 70.63 years, while for females, the average life expectancy is around 75.67 years.
In relation to what Amanda is saying, if there are more numbers in the lower region, your average is going to be lower, and if there's more numbers in the upper region, your average is going to be a lot higher.
So what you're trying to say here is that the only reason the male's average life expectancy is a bit lower than the female's average life expectancy is because when you're comparing each set of data, you can see that the female life expectancy occurs a lot higher than the male life expectancy.
Yes, that's exactly why the average female life expectancy seems to be higher than the male's average.
And what about the median? Isn't that sort of the same thing as the mean?
The median is actually a completely different number. For example, the male life expectancy median is 71, which means it is the middle value among all the data. Since the median for female life expectancy is around 77.12, this can help us show that the data compared to the middle of the distribution, which is called the central tendency.
And what's with the standard deviation? Is it a good or a bad thing that these numbers are below zero?
For the situation, since the graph shows the life expectancy being the dependent variable, it gives us the idea that since the coefficient is below zero, that would mean the trend line is decreasing as well, making the graph show a slight shift going down ever so slightly, hence why the numbers of both data are very low and close to zero.
And what about the correlation coefficient? What's that all about?
According to both female-male correlation coefficients, since these numbers are decreasing, this would mean that the higher percentage of HIV a country has, the lower the life expectancy is going to be, due to the fact that the trend line is moving from the upper left corner down to the lower right corner as more data is included into the scatter plot. Having a low correlation for both male and female data is a result of the outliers that are not near the trend line, where it can easily skew the data. Also, not having a lot of data can make these correlations appear less reliable due to the fact that when you have more data, predictions are going to be closer to the actual experimented numbers found.
There are also things called outliers. The box and whisker plot shows that there aren't any. We know this because there are no points that are extremely distant from the rest of the data. If there were outliers, the box and whisker plot would have shown those as separately plotted points. There are no outliers because when discussing life expectancy within countries, we know that there are not many countries where the life expectancy is below 50.
Although these stats are calculated exactly from the tables that we have found, there are multiple factors that can skew this data.
Isn't the data they gathered only from 30 countries? How would this affect the data?
Since we have only 30 variables for each, we picked the countries with a higher percentage of HIV because we made an assumption that these countries had a higher percentage. That would mean their life expectancy would be a lot lower due to the fact that our research that we found before told us that HIV does affect a person's physical and mental health. Looking at our data and coming to a conclusion, HIV is not the only thing to affect a person's health in their decrease in their life expectancy.
When you compare first world countries to third world countries are going to have a higher life expectancy, not just because they have a lower percentage of HIV occurrence. In third world countries, we can make an assumption that due to low poverty and less money, they aren't going to have the resources like medication and newer technologies to help heal a person if they have HIV.
HIV is not the only disease that can be life-threatening. There are many factors for why a country's life expectancy can be high or low, therefore causing a limitation within our data. If a country does not have the right resources that people can refer to, it's harder for them to fight these diseases. This can create a lower life expectancy. Some countries have more resources than others, thus creating a difference in the ability to gather information. It is hard to know the exact amount of people that suffer from HIV.
Looks like we're out of time here.
Please tune in next week to get the latest news.
Bye.